So let's talk about displacement. What is displacement? Displacement is the change in your position vector. It is not the same as distance. There's the biggest mistake that I've seen my students make in the past is that they think that displacement and distance are the same thing. They are different. Displacement is a vector. And what that means is that it's allowed to cancel. So for example, if I start right here and then I move over here, I have displaced myself about a half a meter to the right, as far as I'm concerned, probably to your left. So displacement has a direction associated with it. You can't just say your displacement was 3 meters. Your displacement was 3 meters to the right. And it's important to represent that because if I move a meter to the right, it's not the same thing as me moving a meter to the left. Same distance, not the same thing. All right? Displacement can also be allowed to cancel. So if I start here and then I displace myself and then I displace myself again, my displacement now is 0. The distance that I traveled was not 0, but the displacement is. All right. So displacement is a vector. If I start here and then I go here, my initial position was this one. Here's the origin. The initial position vector is this one to point 1. The final position vector is this one to point 2. So my displacement vector is final minus initial. So it's this vector right here. Delta R. R2 minus R1. Okay? Notice that it's a vector and it's exactly what we mean by displacement. You start at 1, you go to 2. So what was your displacement? Well, it was that. So it's really, really, really easy and obvious, but you just have to pay attention to what it means. All right, let's do a more complicated example. Suppose that I start here at position 1, I go to 2, then I go to 3, then I go to 4, then I go to 5. All right, each displacement goes like this. 1 to 2, 2 to 3, 3 to 4, 4 to 5. Now, if I want the net displacement, it will be this displacement plus this one, plus this one, plus that one. Now, of course, you know what it has to end up being. Because what is the net displacement from 1 to 5? That's it, 1 to 5. And that is what you'll get if you add all those vectors together. It'll just be more annoying to do that than to just draw that vector that goes from 1 to 5. The reason why it's so easy is that displacement is allowed to cancel. So it actually makes displacement much easier to calculate in general, especially in complicated problems, than distance. Notice if I wanted to know the distance that I traveled, I would have to find the length of that vector, the length of that vector, the length of that vector, and the length of that vector, and then add them all together. And I don't want to do that. I want to just draw a red vector from 1 to 5. And that's why displacement is easier. All right. Now let's just do a real simple example. In one dimension, I don't have to really worry about vectors because a negative sign will carry all the information about dimension or about direction that I need. So displacement equals x final minus x initial. Let's say that I started at 5 meters and I ended up at -3 meters. And I wanted to know what's the displacement. Well, final minus initial, -3 minus 5. So the answer is -8 meters, or sometimes you might say it as 8 meters to the left. And that's displacement.